So this is going to be a little video about how to determine valence electrons in atoms. I'm going to start by writing a couple of them, configurations down for you. We'll just start with calcium. So calcium, it's hard to see that number, but it's number 20. So 20 valence electrons, the first two would go in the, or excuse me, 20 electrons, not valence electrons, 20 electrons would first go in the 1s, then the 2s, and it would hold 2, then the 2p, notice how I'm just following through the table here, and it would hold 6. 3s would be 2, and 3p, it has some students in the room, so you'll hear some background noise. It'll hold 6. And then 4s holds 2, and then we're at 20. See, 2 plus 2 plus 6 plus 2 plus 6 plus 2 equals 20. Well, of those 20, only these two right here are in the outer shell. That's the highest energy level, the fourth energy level. So only those two are in the highest energy level. All right, then if I go to, say, something like nickel, right? So nickel has 28 electrons. So we'll write the electrons configuration down: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. So now I'm up at 2, 4, 10, 12, 18, 20. In case you're, just to review how I got all these numbers in order, 1s is first, then 2s, then 2p, then 3s right here, then 3p right here, then 4s right here, then 3d starts right there. See the 3d? Now nickel's the eighth one over, 1, 2, 3, 4, 5, 6, 7, 8, so it ends in 3d8. Still, the highest energy level is the fourth one, and there are only 2 electrons in it. So you'll notice that always happens when you're here. So 3d is preceded by 4s, and 4d is preceded by 5s, and 5d is preceded by 6s. So you never have a d in the outer shell or an f. Okay, now I'm going to go to something like oxygen, right? So oxygen sitting right here has 8 total electrons: 1s2, 2s2, 2p4. So there are 6 in the outer shell. The outer shell is the second energy level. It's the second energy level, 2. So there's 2 in the 2s, and there are 4 in the 2p. Together that makes 6. Notice that if you start counting these columns, 1, 2, 3, 4, 5, 6, and then 7 and 8. Oxygen's in the 6th column. Turns out that everything in this column has 6 in its outer shell. The difference is oxygen ends in 2p4, sulfur will end in 3p4, so 3s2, 3p4. Selenium will end in 4s2, 4p4, and so on, but they all have the same total in their outer shell, which is 6. So 1, 2, 3, 4, 5, 6, 7, 8, and all these theoretically should have 2, because the D's always got a higher S in front of it. Okay, now with that being said, I'm going to share screen for a minute and drag this other periodic table in. This was the strange names periodic table. Looks like this. And we have the test. Let me see if I can shrink this up just a little bit. And the actual valence electron section of the test look like this. All right, so first question said, let's put that in there. The first question said, what is the number of valence electrons in rhino? And I have the answers listed here. So let's see if we can figure out why it is. I'm going to find my strange names table again. There it is. And put that right in here. All right, so there's our strange names table. So the first one was rhino. So rhino was right here. Notice it's in the 1, 2, 3, 4, 5th column, so it'd be 5 in the outer shell, and that's why the answer is 5 for rhino. In dog, go back to the strange names table. Dog's in the 1st column. That's why the answer was 1 for dog. How many valence electrons in house? So house, you got to find. It is here. It's in the 1, 2, 3, 4, 5th column, so 5. That's why the answer is 5. In cabin, so you find cabin. Carbon's here. It's also in the fifth column, so it'd be 5. The next one was gerbil. So gerbil, excuse me, gerbil was sitting right here, second column, so 2 in the outer shell. Aluminum. Aluminum was one that I put on there just to throw a regular element in. So aluminum's here, 1, 2, 3. There's 3 in the outer shell because aluminum's sitting right there. So 3. That's why that answer's 3. Then we had cavern and camel. So cavern, camel was here, cavern's over here. So cavern has 7. So it was 1 through 8. That's 8. That's 7. And then camel would be 3. So cavern 7, camel 3. Then we have alpaca and kitten. So alpaca, right here. So 1, 2. All these have 2, 3, 4. 4 for alpaca. And then kitten 1. It's in the first column. Now remember, this periodic table is essentially the same as this periodic table, except that on the strange names periodic table, I did not put anything below the 3D. It just goes down to the 4th series. So if you go 1, 2, 3, 4, it comes across here, and then I left off all the bottom stuff. All right, so that's how you do valence electrons.